These are the references. Thank you, sir.
Yeah, Teja.
Yeah, sir.
You said
Sir,
that you have
one
used...
second, sir. Sir, 1 second. Teresa, please let you go to the first slide. Just now I started recording. I forgot it. Move back to the first slide, just for recording purpose.
Okay, sir. I'll be starting from like.
Okay. Okay, sir. Sir, you can carry on.
Yeah, you can. I think you can. You take the screenshot.
Yes.
Okay. Teja.
Sir.
You said you have used different machine learning techniques for finding the accuracy.
Yes, sir.
How do you? What is the data set? From where did you take the data set? How many samples of data set do you have?
Sir, I took the chats from my phone, sir. Like we can't ask like random people for WhatsApp chat because it is like we have to upload our chats. So I took my chats and classified it.
So how many features? Because machine learning algorithms require attributes.
Yes, sir.
What are the attributes for your data?
Which data, sir? Like exactly.
What exactly you have done? On which data you have worked? On which data you are showing the accuracies? On which data you have applied machine learning algorithms?
I applied on spam detection, sir.
That is what I'm asking. How did you apply the machine learning algorithms without attributes?
Attributes I use, sir, because in the messages we'll be having I use what you call one algorithm, sir. Let me just give me a moment. I did not paste it here. I took like there will be file call. Let me check that file.
See, whenever you have used machine learning algorithm, you should be able to
Yes,
actually explain about the data. What
yes,
are the
sir.
attributes? What is the known? What is the class? How many classes are there?
Yes, sir. So actually, I took reference from the like these papers, and I was able to implement all these things. So there was one file, like in the text file, there were many words which were encoded as spam. So if we have all those words in our chat, that is like encoded as spam. Otherwise, if we don't have all those things, this is not a spam. So it is here we can see that ham messages. These are called as ham messages. I use this kind of thing. I took the ham message file, and I uploaded, and I tried to detect using that.
Okay, Teja, I think you should have a little better knowledge on this actually, because your attributes must be clearly defined.
Sure, sir. I will work on it.
Yeah. Okay.
Thank you, sir.
Thank you, Teresa.
Thank you, sir.
Next, paper ID 71. Anybody is there? Paper ID 71, a feature selection technique based approach for author profiling using word embed technique. Kavuri Karunakar. I think already joined, right? Paper ID 71. Sir, your voice not audible, sir. We are not getting your voice. Karunakar gar. Yeah.
Sir, is it audible?
Yeah, it's audible, sir.
What
Just
about
share your
65?
65 not responding, sir.
Okay.
Waiting for that one. I think he is also one of the coordinator for session 2, sir. Technical session 2, AML.
Okay.
65.
Okay, sir. If 71 paper is ready, then we can go ahead with it.
Okay, sir.
Hello, sir. Hi, sir. Good evening, everyone. Good evening to the chair. My paper titled as a feature selection technique based approach for author profiling using word embedding techniques. So this is the agenda. First, I want to discuss about the authorship analysis, then author profiling and its applications. Later on, a simple literature survey, and what is the data I considered for the experiment. Later on, different objectives like feature selection algorithm, word embedding techniques, similarity measures, word measures, and all with the results I will explain. So first of all, I want to give the brief introduction about the authorship analysis. Basically, the task is related to author profiling. Authorship analysis can be divided into two types: author identification and author profiling. Just authorship analysis means it's a classification task, classification of text into different classes. Other profiling is my main research topic. It's just about the predicting the demographic characteristics of an author based on the writings. So we have a tremendous information in the web related to the tweets and some reviews and some comments like that. So in order to get some information for the unknown data, we are using the other profiling. It's a just classification technique. And the remaining other verification and other attribution are two different tasks. Other attribution within the other attribution just determining who wrote the text document. Just we are trying the machine with, for example, 10 others documents, and finally we come to the conclusion who wrote the text for unknown information. As well as the other verification, it's just total the information related to single author, number of documents trained to the model. We will get whether the document is written by that author or not. These are the three tasks. My research objective is the author profiling. This is the total information, other verification, other attribution, identification, and all. So the competition can be conducted by the PAN competition. It consisting of plagiarism detection, other attribution analysis, like that. All the different types of competitions are there. I would like to take the information and data set from the PAN competition only. And here is some introduction part related to this authorship analysis. The basic thing is other profiling. It's all about predicting the characteristics of an author for anonymous data. So whatever the data without having the different characteristics like whether the text is written by the male or female, whether the text is related to the which age group, what is the personality traits of the document author, and the what is the country and what is the location he belongs to. So the text didn't mention any information. We need to tell the information based on the classification technique. So this is the other profiling, predicting the gender, age, location, nativity, language, educational background, and all. And the applications related to this other profiling is where we can use literature research, forensic analysis, advertisements, marketing, all those places we are using this other profiling technique. So the abstract, I already said the World Wide Web having numerous information of data. So in the other profiling is the one technique used by the research community. So other profiling technique used in several text processing applications like what already told you, forensic analysis, marketing, and all. So in order to do this experiment, we need to consider different types of features. The text having number of features like stylistic features, content-based features, content-specific features, like that. So within the one of the text objective is the feature selection algorithm. We need to propose a new feature selection algorithm, and sometimes we are using the same proposed algorithm and with different word embeddings, like that. So we proposed a feature selection. In this work, we proposed a feature selection algorithm, not proposed. Just I am used one feature selection algorithm, that is the cosine similarity measure, and the data set from PAN competition, and the similarity measure what I used to find the similarity among the words. Similarity words, after that all the words can be grouped together. It is called a cluster. The selected words are used to representing the word documents, that is called document vector. That document vector given to the classification model. Finally, you will get some based on the some evaluation measures, we will get the accuracy. So which algorithm works well on these word embeddings, I will tell you in the later presentation. So this is the literature survey pre-processing. Before we need to give the data to the classification model. For that, we are not directly giving to that one. We need to represent that one into the numerical representation. So before that, the text must be cleaned. For that, HTML cleaning to obtain the plain text, deletion of all the URLs, deletion of punctuation marks, and some invalid, some emoji symbols must be removed. The case is converted into the lowercase, stop word removal. So in order to analyze the text, no need of some unimportant words like a, and, the, under, behind, before. Those are the no that much of discriminative power for those words. That's why we remove the information from the trained data. Stemming, in order to find the root word, we are using the stemming. Later on, what are different types of features are there? So previous researchers works on word-based features, syntactic features, structural features, character-based features, stylistic features, and all number of. Now I am working also content-specific features, and how I am working, what are the modifications I did in the content-specific features, I will tell. So these are the different types of features. So I need to represent in my previous work, I define new stylistic features. After that, I move to the content specific features, word based features, total number of words within the document, n-grams, two character length words, 3 character length words, like that. And how many words starting with the capital letters, how many words, what is the ratio of white spaces, non-white spaces. These are all the information to analyze the text. So syntactic features, textual features, all those things are there. Later on, same classification techniques, Navi Bayes model, random forest, logistic regression, and SVM. So many are there. I am experimenting with the SVM and the random forest. So this is the data set. I am used 2 data sets here. One is the PAN 2014 review data set, and other one is the PAN 2016 data set. So both are related to the gender and age group. Actually, gender is the binary classification related model, and age group is a multi-classification. Here I am dividing the age groups into 5: 18 to 24, 25 to 34, and 65 to later on. So number of documents I considered here is 2080, total 4160 documents. Same documents divided into number of age groups, 4160. So this data set can be used for the experiment. Here also some data set, number of documents related to the one author having number of tweets. Okay, number of documents are 2018 related to the female, and now 2018 related to the male, and those 2018 consisting of number of internal tweets, those are totally given as this number. Okay, so this is my proposed model. First, the data set. After pre-processing techniques, after stemming, lemmatization, stop word removal, I will get the cleaned data set. From the clean data set, extract all the words, whatever the word within the document from all the data set having, for example, 4,000 documents, each and every document consisting of number of words. I will extract all those words. Later on, I will apply embedding techniques. So from that embedding techniques, I will get the word embeddings for each and every word. So after that, I will get the word vectors. That means the textual information can be converted into the numerical information in the form of word vectors. Now, for example, I will for example, there are 10 words are there. So I will apply the similarity measure among the word vectors. So for example, I compare first two word vectors, first two words. So if it those two are belongs to having the similarity, then I will put within the cluster. So likewise, I am having number of clusters. Within the cluster, I will put number of words which are related to that cluster. After that, select the important words from each cluster. Now the total number of words, for example, 2 lakhs. So each cluster, from the each cluster, I will take only important words. So that's why automatically the total number of words can be reduced. Only those words can be used for the experiment. This is called dimensionality reduction. So by using the feature selection algorithm, the similarity measure, cosine similarity measure, the total thing can be reduced. After that, by using these words, I will prepare the document vector. So that document vector finally feed to the machine learning algorithm. So by using finally the machine learning algorithm gives the accuracy about the age and gender. So here is the word embedding techniques. The first step is total words can be converted into the word embeddings. Here I am used the 4 techniques: word to vec, glow model, fast text, and BERT. The word to vec is a two-layer neural network model. It's a shallow 2-layer neural network model. It gives the it take the text as a data set and produce the vectors for each word. It's good in retaining the semantic relationship. A lateral glow model, it's a global vector. So whatever be the some drawback in the word to vec, that can be rectified in the glow model. Then the fast text can be developed by the Facebook. One of the other team, McAlow, can propose this fast text. So all those 3 can give the 300 dimensions. For each and every word, 300 dimensions. Later on, I go for the BERT model. In the BERT model, there are 2 types of BERT models always. Both are pre-trained models. Actually, the word to vec can be created based on the Wikipedia data. But the BERT model, there are 2 types of BERT models. One is the BERT base and the BERT large. So how many number of dimensions will give in the BERT base is the 768 dimensions. BERT large give 1024 dimensions. So when you work with the word to vec, there are only 300 dimensions. When I work with the BERT model, I experimented with the only BERT base. Okay, small one, 768. So automatically the number of values can be increased. It can be very helpful to the experiment in order to get the perfect accuracy. Okay, so once all those word embeddings in my hand, I will apply the similarity measure. In the similarity measure, it's a feature selection algorithm. The similarity measure compare all the word embeddings, finally, which are similar. For example, man is related to the king, the woman is related to the queen, and brother is related to the sister, and man is related to the brother, sister is related to the woman. Likewise, whatever be the similar words are there, those are put into clusters. From each cluster, I will take some words for the document vector representation. Here is the formula for cosine similarity measure. So cosine similarity measure will give the three values. Those 3 values are 1, 0, and -1. If the 2 vectors are closely related, the angle is very less, then it is closely related. It gives the greater similarity, that is the 1. And those 2 are orthogonal. The cosine degree is the 90. If the cosine degree is the 180, those two are opposite vector. So it will give the -1. So if the words are closely related, similar, then the angle is the very less. The angle is the below 90 degrees, like that. So here is the how many in my experiment there are number of documents. I am comparing document A with document B. The TK is the term related to the document A, and the TK is the term weight related to the document B. So based on the normal similarity measure formula, I compared and I calculated the similarity measure among all the word embeddings. The word embeddings later on I compare the cosine similarity measure, I calculate the cosine similarity measure. Now in my hand, only the clusters. The cluster consisting the number of words.
Sir, time up.
Sir?
Your time is over. Please go to the results and conclusions.
Yeah, sure, sir. So these are the evaluation measures, accuracy, and the experimental results. The word embedding technique, word to vec glow model fast bed. I used the SVM and random forest, and finally I got the 0.90% of accuracy with random forest but model, as well as for age also 86%. And it is for the FAN 2016 data set. One is the FAN 2014 data set, and this is the FAN 2016 data set. Here the BET model and random forest gave us a good accuracy when compared to the remaining embedding models. The conclusion. So several researchers proposed number of different profiling, other profiling tasks based on the different varieties of feature selection algorithm, content-based features. I used cosine similarity measure and word embeddings. This is the new one. And for one more thing, and for term weight measure, I proposed a new one that will normalize the total document numbers. That is the new technique actually. Future scope, in future I am planning to work with the auto encoders for selecting the features, as well as some deep learning techniques like GANs for classification purpose. So my work can be moved forward by using the deep learning techniques.
Time complexities. Have you done any evaluation of time complexities for the all the experiments that you have done?
No, sir. Time complexity, I couldn't go work on the time complexity.
When you are working with different algorithms, you should also
different algorithms. Yes, sir. Different algorithms.
Okay.
As
And
well
have you also compared with any other work? You have shown only comparison of algorithms that you have tested. Have you compared with any other similar work, who has used the same data sets?
Yes, sir. Yes, sir. In the literature survey, the best accuracy is the 82%, but with the random forest only 82%. I proposed a new term weight measure.
What is the size of PAN 2014 and 16 data set, sir?
Sir, one is the 3.4 GB, PAN 16, and PAN 14 is the that one is the 3.4 GB, and PAN 2014 is the 1.4 GB, sir.
Okay, then how much time it will take to prepare the data set?
Sir, actually 6 hours.
Processing stage and feature extraction.
Yes, sir. 6 hours. In order to train the model, it will take the 6 hours of time, sir. I am using the configuration of 8 GB RAM. 6 hours
okay,
of time.
Sir. You can sign off. Thank you.
Okay, thank you very much, sir. Thanks, okay.
Thank you, sir. Karunakar garu. Next, next paper ID 72, D. Mohan Sai Dinesh. Sir, are you ready to give the presentation? Mohan Sai Dinesh. Paper ID 72.
He did not log in. I think Rizwan and Kantaraju are available.
Next, Rizwan, sir. Paper ID 85.
Hello, sir.
Will you
Good
give
evening.
Okay, sir, are you ready to give the presentation?
Yes, sir. I am ready to give the
Okay,
presentation.
share your screen, sir.
Sir, is my screen visible? PowerPoint presentation?
Yes, sir.
Okay, sir. My voice is also audible, no, sir?
Audible, sir. Audible.
Thank you. Thank you very much. Good evening, everyone. Good evening to the chairperson as well as the other members present here. I am Dr. Rizwan. I will be presenting a paper on behalf of my co-authors as well, Dr. Sendamare and Dr. Dinesh Kumar. We belong to the Department of Statistics, Manonmani and Sundaranath University. The title for my presentation is Hyperparameter Optimization for Gradient Boosted Tree-Based Machine Learning Models and their Effect on Model Performance. A little bit of background on why we started this work. Gradient boosted tree-based machine learning models have several hyperparameters, we all know. When we run these models using softwares like R or Python, the default settings are usually used to train these models, which are unlikely to produce optimal results. The three commonly used machine learning models in this field are extreme gradient boosting model, light gradient boosting model, and cat boost model. Cat boost model is a recent development in this field. Coming to grid search. What is grid search? As I said in the previous slide, all these boosting models have several hyperparameters. Each hyperparameter will have a specific value, at least hypothetically speaking, and a combination of these hyperparameters will provide the best model accuracy or performance. However, there are several techniques or methods to arrive at this specific combination of hyperparameters. There are three basic optimizing algorithms for hyperparameters. One is manual, where we supply the manual values. One is grid search, and the other one is random search. There are other optimizing algorithms as well, but I have taken here the common ones. Among these methods, grid search is a simple method and computationally manageable. So when we talk about many people who are doing machine learning, their resources will be limited and they will not be having access to high functioning computers or even cloud computing resources. They will be mostly using personal desktops or laptops. But this algorithm, this grid search, provides a reasonably good coverage of the search space, and it is computationally manageable, and it is not very heavy on the resources. Grid search finds the best set of parameters by generating a Cartesian product of all possible combinations within the specified ranges which are provided by the user. So we provide the ranges, and within that range, the grid search tries to find the optimal combination of hyperparameters. The advantage of grid search is also that it helps us finding a global optimum, even if it is a little slow. So at the price of speed, we are gaining something which is very less resource intensive. When I did a literature review, I found several papers which have worked on other optimizing algorithms like random search for neural networks, particle swarm optimization for SVMs, genetic algorithms for different machine learning problems, Bayesian optimization for XGBoost, and SVM with Bayesian optimization. So all these papers have concluded that hyperparameter optimization is always useful, but none of them found any, but none of them have investigated this grid search method for gradient boosting models. So that is why I carried forward this work, because I wanted to understand whether this simple algorithm can be useful for gradient boosting models, which are very popular these days. So a lack of a systematic investigation of grid-based hyperparameter optimization strategies led me to do this work in this paper. The objective was to show how hyperparameter optimization affected the performance of three commonly used boosted tree machine learning models compared to no optimization methods. The data that I used for this demonstration was extracted from an online food delivery application, where several characteristics about the restaurant, like type of cuisine, franchisee restaurant or not, vegetarian restaurant or not, newly added restaurant, working hours, and some food item characteristics, like whether it is a vegetarian food, tags like recommended, bestseller, new item, chef special, must try, or healthy, the food nutritional value like calorie, protein, fat, and food price were extracted. These are the three commonly used gradient boosted tree-based machine learning models that I have used: XGBoost, LightGPM, and CatBoost. All these are open source implementations. Hyperparameter optimization, as we all know, can be mathematically represented as follows. For a given data set X train, lambda is the set of hyperparameter combinations that reduces the expected loss L over X samples taken from the true distribution G of X. So this lambda will need to be chosen to minimize the generalization error. In order to demonstrate the effect of hyperparameter optimization, we fitted three models to the data for the prediction of calorie content of food item. So that was our outcome variable, calorie content of a food item, which is a continuous variable. So this was a regression problem. We did it with and without optimization. And the hyperparameters that were selected for optimization for each of the three models are shown here. Number of trees, tree depth, learning rate, eta, number of predictors to try at each split, sampling fraction, loss detection, minimum number of data points at each split. For light GPM, we used, in addition to the above, lambda, alpha, and number of leaves. And for CatBoost, L2 regularization. So a little bit about grid search. The dimensions of the grid are determined by the number of parameters and the limits of the grid, which we specify in the range. For a given number of parameters k and n values specified, the complexity of the search space is given by n power k. So we used in this problem a grid size of 500. The model performance was evaluated using standard regression metrics like R-square, mean absolute error, root mean square error. And the objective of the optimization algorithm was to reduce MAE, RMSE, and maximize the R-squared. Coming to the results, here I have shown the figures and the results for no optimization. So without any optimization, we found that XGBoost was the best performing model in all three parametrics, in all three metrics. It had the lowest MAE, 42.3, 80.4 RMSE, and the highest R-squared value, which was 0.67. The second model was light GPM, and the third model was CatBoost. So CatBoost was not really performing well without optimization of the hyperparameters. This figure shows the hyperparameter space that have been investigated for each of the three models. The top panel shows CatBoost, the middle panel shows light GPM, and the bottom panel shows XGBoost. And since the number of parameters are different, the number of boxes are different. The grid search clearly shows us that this entire space was searched for the optimal set of hyperparameters. Since the learning resources or the computational resources were limited in my case, I have used a grid size of 500, but depending upon the resources, this can be increased to much more. In this figure, I have shown the performance of results on a tuning grid containing various combinations of hyperparameters. The reverse happens when we do the hyperparameter optimization. XGBoost model had the poor performance compared to the other two models. So here for each of the 500 combinations, we have plotted the model performance on three metrics: RMSE, MAE, and R-squared. Here we can see the same. With hyperparameter optimization, CatBoost performed the best with a mean absolute error of 22.1, RMSE of 74.9, and R-squared of 0.77. In addition to this, what was interesting is the performance of all three models improved after optimization compared to no optimization. Although the ranks changed, which was expected, but all three models improved performance compared to no optimization. So CatBoost came first, light GPM followed by XGBoost. In out-of-sample testing also, where we used the testing data set, which was unseen data, the best model using optimization outperformed the best model using no optimization. So we can see that RMSE decreased by 10 points, MAE decreased by 10 points, and R-square improved by 6 percentage points, which is a remarkable improvement for this type of data set. In conclusion, hyperparameter optimization yields the best model performance regardless of the model used. Grid method of optimization works well for gradient boosted models, especially in resource limited settings. It seems that the method of optimization is highly contextual, depends upon the data set and the problem at hand. For a relatively large data set with 5 to 10 hyperparameters and a reasonable amount of resources, grid search produced optimal results. And the recommendation from this is hyperparameter optimization should be a standard procedure when building tree-based machine learning models. Thank you, sir.
Thank you, sir. Good presentation. Rizwan, sir, have you compared the time complexities of the different algorithms that you have used?
No, sir. I have not used, but I will try to learn more about time complexities, because I'm really not sure what time complexity in this particular instance means, but I will try to find out and do that, sir.
Okay, sir. And you said that there are 5 to 10 hyperparameters.
Yes, sir.
Did you disclose or did you give a list of those parameters, or before optimization and after optimization?
Sir, all the parameters, all the hyperparameters that were used were present both before as well as after optimization.
Did you give the list anywhere? Did you show,
Yes, sir. Yes, sir.
the parameters?
Yeah, yeah. In one slide I showed it. I'll share it again. Sir, are you able to see, sir?
Yes, sir.
So for XGBoost, these were the hyperparameters: number of trees, tree depth, learning rate, number of predictors to try at each split, sampling fraction, loss reduction, and minimum number of data points to try at each split. For LightGBM, all the above parameters, in addition, lambda, alpha, and the number of leaves. For CatBoost, the leaf regularization was also used.
Okay, okay, sir. What I'm asking is, what are the optimized values? Like one example, did you quote anywhere?
Yes, sir.
Or what are the values after optimization?
Yeah, yeah, I got your point, sir. I have not showed it in the presentation.
Okay, yeah, I understood that here the parameters are same, but my question is that after optimization and before optimization, what are the values?
Yes, sir. Yes, sir. Yes, I will try
Because
to add that, sir.
how the algorithm has tuned
We have to
to the
understand.
correct optimized values, and for that values, did you work on a standard data set?
This is not a standard data set, sir. This was a data set which we had used for an earlier work, where we extracted data from an online food delivery application. So this is not a standard data set, sir.
No,
But
because whenever because your problem is on optimization of parameters for a decision tree.
Yes, sir.
So if you want to evaluate your algorithm, you have to prove it on a standard data set.
Okay, sir. I got
Then
your
only your work will be valid.
Sure,
So
sir.
this is my suggestion. Kindly just work on it, and you can obviously go for a good journal if you do it. Actually,
Thank you, sir. Thank you, sir. Thank you very much.
because unless you prove it on a standard data set, work will not be accepted on your own data sets.
I agree, sir. I agree. I see your point, sir. Two things I will have to work on. One is the hyperparameter values before and after optimization, and try to prove it in a standard data set.
Standard data set. Then later you can extend it to your own algorithm, like any food delivery classification or whatever real-time application you want to. You can extend it as a case study. Then it will become a journal paper.
Thank you, sir. Thank you very much, sir.
Yeah, thank you, Rizwan. You can
Thank you,
sign off.
Rizwan, sir. Thank you, sir. Rizwan, sir. Thanks for our
Thank you,
presentation.
sir. Thank you. Thank you, sir.
Still waiting for the remaining participants, sir. I think Sri Aravind, 1 second. Aravind, sir? Hello? Any other paper IDs?
Karunakar's presentation is
Karunakar. Oh, what, sir?
Yeah.
A feature based approach for author profiling used. What, sir? Embedding technique.
Okay.
Karunakar Kavuri.
He is still in the meeting. I don't know whether he is
Yes, sir.
listening
Yes,
to
sir.
the presentations. Then it's fine.
Yes, sir. Karunakar, sir, I think power, right? I think second person. He is the one second person. Aravind, Aravind, sir, your paper ID? Sir, reminding, yeah. So one more person said that due to some traffic issue, he may join at 10:45. Hello.
Hello.
Sir, your paper ID?
Okay, sir. Shall we start the
Your paper ID.
081, sir?
Okay, sir. You can share your screen. Ganesh Kumar.
Yes, sir.
Okay, thank you.
So shall we proceed?
Okay, sir. Sir, welcome, sir. Paper ID 81, sir.
Yes, sir.
Okay, sir. Please carry on.
Hello, sir.
So just waiting, sir. Just a second, sir.
Mohan Sai.
Yes, sir. Sir, I have joined in my mobile phone, sir.
What about your presentation? Can you share your presentation on the mobile?
Please accept in my laptop, sir. It is asking to be let you in. It is
Okay,
waiting
okay.
for your It is waiting for your response, sir.
Sir, so
Okay,
if-
okay, okay, okay.
Open your PPT. I think.
Sir, did you see
Sir.
my slide, sir?
Can I know who is going to present?
Sir,
Paper
Ganesh-
81?
Yes, sir.
Sir.
Okay.
Okay, okay. I think, sir, Mohan Saigar, you please wait after the.
Okay, sir. Okay, sir.
After this, we will take yours.
Okay, sir.
Meanwhile, you get ready.
Okay, sir.
Yes, shall we start, sir?
Okay, sir.
So slides are showing, sir.
No, sir. Open it. PPT is not open. Open your
Okay,
PPT, sir.
presentation we start, sir. It's just a problem.
Sir, your screen is sharing, but PPT is not open.
Sharing.
Sir, we can see the downloads folder. In the downloads folder, you double click the paper PPT.
Okay, sir. PPT. Sir. So PPT is opened, sir.
But we are not able to see it.
So now,
No, you do one thing, sir. You just once again you unshare it, remove the sharing, and once again share the full computer, full screen.
okay, sir. Okay, sir.
Okay, now open the PPT, sir.
So now,
We are only able to see the folder, not the PPT.
Sir, you just double click your PPT, sir. You just double click.
so I already double clicked, sir. In my system, the PPT was opened, sir.
No,
Okay.
no, sir.
There is some issue with the screen sharing. I don't know. We are not able to see your presentation.
So wait, just a minute.
Sir, or you can just come again. Meanwhile, if where is that other person?
And that person is already left it, sir.
Oh,
He said that just wait for a minute. So he's thinking that he is waiting for outside, sir.
okay.
Just now, sir. Yes, sir. Yes,
Now
sir.
we
Okay.
can see.
Okay.
Now we can see. Please put in full screen mode.
Abba.
Ganesh sir. Ganesh sir.
Ganesh sir, again you have unshared it.
Sir, did you see my slide, sir?
No, no, sir.
No,
No,
it
sir.
is not. No, you have shared and again unshared, sir. Actually.
So now,
Mohan,
so now,
no.
Ganesh sir, I think you just check about the presentation, sir. So meanwhile, sir, Ravikiran sir, can we allow Mohan Sai?
Yes. If he is ready, we can, sir.
Okay, sir. Sir, Ganesh sir, just wait for a Ganesh sir. You just check it from your side, sir. So Mohan Sai, sir, are you ready to give the presentation?
NK screen கொடுங்க இல்ல விண்டோ மட்டும் கொடுங்க
Mohan Sai there.
இது அப்படியே ஷேர் ஆயிடும். நீங்க இங்க என்ன ஓபன் பண்ணிருக்கீங்க?
Mohan sir.
இப்படி ஓபன் ஓகே. இப்போ ஓபன் ஆயிடுச்சு.
Mohan sir, please respond.
Yes, sir.
Are you ready to give the presentation? Mohan sir. Okay.
Okay, sir. Ganesh sir, you can continue. Share it in full screen mode.
Yes, sir.
Yes.
Okay.
Yes, continue, sir. Start.
Hello, good evening, sir. Did you see my slide, sir?
Yes, we can see, sir. Please continue.
Okay, sir. So thank you for accepting my paper, sir. So this is Ganesh Kumar. So we are going to present a paper, Advanced Machine Learning Approaches for Improving Traffic Flow Prediction in Smart Transport Systems. So in this proposed system, so we are using the three types of algorithm, the KNN algorithm, random forest algorithm, and the ARIM machine learning algorithm. So in this proposed system, we are comparing the three algorithms. The best result is produced in random forest algorithm, because so comparing to three algorithms, it will produce the 95% of time flow consideration. So the main motivation of our paper is improving accuracy, real-time monitoring, optimization of traffic flow, and cost efficiency. So here the introduction of our paper. So here I am going to tell about the four conditions we are approaching in this paper. So the four conditions are true false, true positive, true negative, false positive, and false negative. So here the main approaches for artificial intelligence technique such as machine learning method. So to develop a new model and framework for traffic flow prediction to enhance its performance. Here the main literature survey I have written. So here the main literature survey for two different algorithms for prediction. One is online prediction and offline traffic prediction. So online prediction, offline prediction is mainly for accuracy, prediction, and recall. So three parts we are considering like that. So accuracy using for number of current prediction and total number of predictions into 100%. It used to give the accuracy formula. Then so second paper is used for cost sensitive support vector machines. So in this tool we are using for classifying the method called ASM gentle add boost method. So here using for mainly purpose for shortest term memories. So third one is using for past and present data in a continuous manner. So third one. So fourth one is used for SVM with the quadratic discourse capacity. In this proposed method, we are using for collect and prepare the data, choose a model, train the model, and test the model. Fine-tune the model and implement the model. There is a 6 model we are using for the proposed method. So this is our result and analysis. So here we are using the three types of algorithm, KN algorithm, random forest algorithm, and ARIM algorithm. So compared to 3, so you can see the accuracy, it will display the 95%. So compared to both, and precision also, and recall also. So compare with, so we can reach it is used to reduce the time traversals. So compared to the time traversals will reduce for 94 seconds. So compared to other algorithm. So here we are using to conclude that, so time taken is main for all the purpose of using all the things. So using this algorithm, we can reduce the time, then we can reach the destination at the particular time. So in that, the future scope is that
The future scope of this paper to integrate with IoT, then protective maintenance and environmental consideration and multimodal transportation. So these are our future scope of this paper. So these are the some reference for using this production method. Thank you, sir.
Ganesh sir,
Yes, sir.
what is the data set that you have used for this work?
Urban traffic data flow protection.
So did you mention it anywhere in your slide?
In that
Regarding the
slide, I
data
did
set?
not, no, sir. In that slide, I didn't mention, sir.
No, you have to definitely talk about the data set.
Yeah, yes, sir.
What is the size of the data set, sir? How many attributes are there? How many rows and how many columns?
Sir, it's more than 7, sir.
What more than 7?
7 rows and 7 columns.
Only 7 rows.
So it's more than 7 rows, sir. I'm saying.
Sir, what are the classes you are used in your data set, sir? What are the classes?
Sir, here.
In your work, in your data set.
Yes,
So what
sir.
are the classes you are used?
Because you are talking about some accuracy.
Yes, sir. Yes, sir.
So there should be some classifier. So if there is a classifier, then there is a class label. So what is the class label?
Sir, random forest method, machine learning method, sir.
Okay. Okay, sir.
Okay. Thank you,
Should
Ganesh, sir.
You should know something about your data, sir.
Sir, shall we tell, sir, in this data?
Okay, okay, you can sign off, sir. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Next paper ID 72. B. Mohan Sai Dinesh.
Yes, sir.
Okay.
Yes, sir.
So, okay. Share your PPT.
Hello, sir. Hello.
Mohan, sir.
Is it visible, sir?
No.
No.
Yeah. Now, yeah.
Okay.
It's visible.
Okay. Good evening, everyone. This is Mohan Sai Dinesh, and my teammates are Arvind and Hussein, sir. Here we are presenting exploring public opinion trends on Agnipath scheme through sentiment analysis and topic modeling on the Twitter tweets. Here are the table of contents, the problem statement, data collection, the pre-processing steps, and sentiment analysis, topic modeling, and final conclusion. The problem statement is recently Government of India has launched the Agnipath recruitment scheme for the soldiers of India. The main drawback of the theme is they are recruiting the temporary soldiers for 4 years. Due to this, there is no job security for the candidates, and they will be again unemployed for after the 4 years of service. And there is no security and extra benefits for the soldiers after 4 years. So due to this, there are many drawbacks has come. About 1,000 crores are damaged and 2 trains are burnt in north side, and many more deaths and suicides are reckoned. We take this as our problem statement, and we are going to observe the trends and the analysis and topic modeling on this data that we are collected. We have collected the data from the Twitter by using the scrapper. We can scrap many more user profiles hashtags by using this. We have collected 50,000 tweets from the Twitter by using the hashtags like Agnipath, Justice for Defense Students, Vadido ya Ardido, and Agnipath scheme. Through this, we have done sentiment analysis. The extracted data may contain emojis, hashtags, mentions, URLs, multilingual data, stopwords, punctuations, and many more noisy data it may contain. Because of this noisy data, we cannot build a model, and the model cannot train well. So we have pre-processed the data by using regex and another NLTK libraries in Python. Next, the sentiment analysis. Sentiment analysis used to determine whether a tweet is positive, negative, or neutral. Now, here we have used a wider sentiment analysis, nothing but valency of a dictionary and sentiment reasoner, because it is a Hugging Face transformer, and it was developed and trained on more amount of data, so it can well trained and a transformer. So it is used. It is a rule-based sentiment analysis tool that is used for social media sentiments. So we have used this model for doing sentiment analysis. And next we have summarized our positive, negative, and neutral tweets by using the spacey by mentioning the frequency of each and every sentence. And we have constructed our word cloud for each positive, negative, and neutral tweets. Next, topic modeling. Topic modeling is a frequently used text mining for discovering the hidden patterns and structures in our data, nothing but positive, negative, and neutral tweets. Here we have used the per topic modeling technique by using the term frequency and inverse document frequency clusters. By using this, we have divided these into overall tweets into topic wise, and here we can see the results. The data are clustered into we have for each and every tweet we are calculating the sentiment intensity and subjectivity by using the Vader sentiment analysis. So based on this two polarity and subjectivity rates, we are using k-means clustering so that we can group into three clusters. So by using the three clusters, we have trained our model by using the SVM to find the accuracy of our model on top of it. So we got the accuracy is 0.95, and we can see the trends of our data percentages of tweets, negative, neutral, and positive tweets. The main conclusion of this is we got 95% accuracy of this. We can also determine as of the study can also determine in June 2022 found that Agnipath scheme was not well known to the general public because it was launched in May or June 2022 by the government of India. As of December 2022, there have been noteworthy change in public opinion towards the program. Many soldiers are against this program, and the negative impact has been drawn to government of India for 4 years and temporary equipment of the soldiers. So these results of the study have valuable insights for the public sentiment and perception of the Agnipath scheme, and could help the policy makers addresses the concerns and raised by the public, and it can be also helpful for the government of India to know the trends of the Agnipath scheme, how it is impacting on the people. So thank you, sir.
How did you get the data set?
By using the EssenceGraph library in Python, sir. Here it is. We have.
Do you have permission to download the data?
Yes, sir.
Or did you apply for it, or is it free?
No, sir. It is free, sir. Twitter data is free, sir.
You said that you have also classified on SVM classifier.
K-means clustering, we divided into three clusters, and we can build a SVM model on top of it, sir.
Yeah, you have built, right?
Yes, sir.
You have used SVM classifier.
Yes, sir.
Then what is the data set? How did you extract the features for SVM classifier? How many features are there?
There are only one feature, that is tweet, and another features that we have manually collected is polarity and subjectivity for each tweet. Those polarity and subjectivity, then we can our output label is our class, that is 0 or 1 or 2 means 0 means positive, 1 means negative, 2 means neutral. So based on these four features, we have built a SVM classifier.
Okay, but how did you convert that to the polarity?
By using Vader sentiment analysis, sir. It is trained on more data. It is a Hugging Face transformer, so that we can calculate for each tweet. For each pre-processed tweet, we have calculated the intensity and subjectivity, sir.
Okay, thank you.
Thank you, sir.
You can sign off.
Okay, thank you, sir.
Thank you, sir. Next, paper ID 86, Hariharan G.
Yes, sir.
Okay. Share your PPT, sir, and then
yeah,
start your presentation.
Good evening, everyone. I'm Hariharan Ji, and I'm talking about how COVID-19 has impacted our society and how we use machine learning algorithms in diagnosing it. So this is the agenda. So our slide PPT consists of all these slides. So based on easy analyzed circulatory blood indicators, for example, certain things like white blood cells in your blood, which indicates if a person is healthy, and white blood cells are something which defends our body against foreign particles or foreign substances which enter your body, and they try to engulf it by completely destroying all the bacteria in our body. And these findings may be used to develop effective and efficient treatment plans for high-risk patients, as well as periodic monitoring for low-risk patients. So this system provides accuracy about whether a patient is of high risk or of low risk, if they need the treatment in the hospital, or if not, they could be treated at home. So a lot of COVID-19 patients get worse quickly and aggressively because during the second wave, we were in shortage of a lot of hospital beds and people were suffering to get one bed. And many people were dying on the way in the ambulance to the hospital. So to prevent this, we needed something to know if a person having COVID-19, if they are of low risk, then they need not go to the hospital. So we think that it requires agile decision making because we need to know the result in a very quick manner instead of waiting for the a COVID test report, or instead of going to a hospital center to keep checking yourself again and again by using the cotton swab which is inserted into your nose. And that could be a problem for certain people on doing it continuously because it hurts them. So our purpose is to provide a predictive machine learning model that identifies a potential high-risk patient for the COVID-19 patient population based on blood circulatory markers. These predictions would help the administrators to make provisions for the scarce hospital bed. So instead of going and we could provide the extra bed to another patient who is severely critical and they could be treated over there and we could save this life. So this model can help in providing better public health and social measures to elevate patient care during the pandemic time, thereby improving patient outcomes at large. So the machine learning algorithms which is used in this is, first one is SVM. A support vector machine is a computer method that assigns labels to things by learning from examples. So using multiple examples, it keeps learning and then it provides prediction data by this. For instance, by looking at hundreds of thousands of reports of both fraudulent and legitimate credit card activity, and SVM can learn to identify fraudulent credit card activity. And just similar to this in our COVID-19 patient's blood report, it could see if whether the person is of high risk or of low risk. So that's how we classify it using SVM. A vast database of scanned images. And just like how we use scanned images for fraudulent credit card activity, we could use multiple patients' blood reports along with the parameters which is given in the data set. And according to that, we could classify the patient. And we use random forest as well. A large number of decision trees are random forests, and those are built during the training phase of the random forest or random decision tree ensemble learning approach, which is used for classification, regression, and other tasks. The class that the majority of the trees shows in the output of the random forest for classification from the mean or average prediction of each individual tree is returned for regression tasks. So just like how multiple trees form a random forest, we require those decision trees which give a particular output, and including all that, we have to classify our COVID-19 patients. And CAT boost is an algorithm also used along with random forest and SVM. So the methodology of a project is done by the user will be able to view the data set to see if the COVID-19 report as well as the data set matches, and they could give the input. They can view the columns. The user can view the columns of the data set and then could similarly give the input. And then they can choose the algorithm among the three. And then they can even view the accuracies of the algorithm. And they give the input of what they have with their report, and then they could view the result. And the system displays the data set. This is for the hospital authorities who are using it on a vast scale. They can also display columns, and they can use training algorithms to train the data set. And they can display accuracies as well as they can take values and they generate the result. So the existing system, the increasing growth of machine learning computer techniques divided into traditional methods and machine learning methods. So this section describes on how COVID-19 testing are classified using machine learning methods that are better than traditional methods. And using the traditional method, sometimes it might not be accurate. So we require machine learning in this. And the disadvantages of the existing system is of low accuracy, and it has high complexity. And sometimes it could not be inefficient because certain people, even if they're tested positive, they might not be aware of it because of using some immediate results such as rapid testing. And for COVID-19 patients, if they require immediate testing, they need skilled professions who are completely covered in hazmat suit to compile with the regulations and then test the patient. So that would be a drawback. So our problem statement is that the traditional method requires large memory because they have to compile data of millions of people, because this was a pandemic which was affecting the entire country. So maybe around, if 60% of a city population was affected, we could not compile it in a memory because it required a lot of memory for this. And they also take a toll on people who tend to do the testing, because multiple people are affected while they test other people, they also get infected. They contract the virus, which goes on and starts spreading to the family members and etc. etc. And this will increase the transmission. So we provide a system which determines, predicts, and classifies patients based on blood circulatory marks or the environment of proper system. The application can be used because it helps in reducing the limitation of from traditional or existing methods. So our objective of the study is to develop fast and reliable method which detects accurately. To design a system, we use powerful mechanisms and algorithms. This is SVM, decision trees, cat boost, random forest, and this is our proposed system. We collect the data set, we load the data set, and then the aspects and description is divided, which is splitting. So the training part goes into machine learning models. The testing part gets tested, it goes for evaluation, and then we view the model accuracy. The training part, machine learning models obtains that, and again it goes for testing. So the advantage of the proposed system is of high efficiency, and it is time saving, and it is inexpensive because we use machine learning, and it has low complexities. So our expected outcome is that a system which categorizes high-risk patients and low-risk patients, or maybe even potential carriers of the virus, because we might not know and we need to be ready for anything, because there could be a sudden rise in the case due to any other external factor. So, and the system also uses blood-based circulatory markers, and these predictions will help in the administrators in the hospital to make provisions for the scars of hospital beds. And consecutively, the model can help in providing better public health and social measures. So this is the architecture of a proposed system. So the user uses the system to view the data set, and then they can give in their inputs. And the system does the training, the model building, and can do the testing and the evaluation. Thank you.
Oh, okay, sir. What is the source of your data set, sir?
Sir, we had to find on various websites, medical sites on Google about patients and what kind of blood markers they use. So these are all present in the white blood cells and different types of white blood cells, like lymphocytes and others.
No. My question is,
Yes, sir.
from where did you download the data set?
Sir, it was done some months ago on some particular website. I'm not able to find the source for it.
You have to mention the source of the data set, sir, in any research paper.
Yes, sir. And we also used our other author Purvi's COVID-19 report, sir. So that also we had added in it, sir.
Whatever you have used.
Yes, sir.
You have to mention the source of the data.
All right, sir.
Okay. Okay, thank you.
Okay. Thank you, sir. Sir, 1 minute, sir. Can I just take some screenshots of this?
Okay, you can. Next, paper ID 265. Dr.Kotari Sridevi garu. Madam, be ready with your PPT.
Okay,
Sir,
thank
is
you
it
so much, sir.
possible now because our first author isn't ready yet because our scheduled time was 8:45.
Okay, okay, madam. Okay. Now, are you ready to give the presentation, madam?
No, sir, that's what I'm saying.
Oh, okay. At what time, madam, will you give the presentation? I think you were first.
I am the one who's going to give the presentation. So yeah, we
Okay.
were prepared for 8:45 and ma'am was gonna join around 8:15 actually.
Okay, okay.
At what time can we present, sir? Then I'll just inform so that we are ready by then.
Madam, only 2 papers are pending, madam. 46 and your paper only.
Okay, okay.
Remaining all are over, madam.
Okay. Fine. We were going through the schedule. Fine. I'll inform, sir, once.
Okay. Sir, Ravikiran sir, paper ID 46, the person is asking about 10 minutes time, sir. Maybe 8 or 8:05. The person will join the
Oh,
session.
okay, sir. No problem.
Paper ID 46. Hanishman Sharma. Paper ID 46.
Yes, sir.
Are you ready to give the presentation?
Shall I present my screen, sir?
Share your screen, sir.
Okay.
Share your PPT.
Sure. Sir, is it visible? Hello.
Sir, we are not getting your voice, sir.
Hello.
Hello.
Hello. Yeah, is it visible, sir?
Okay. Go back to the first slide, sir.
Sure, sure.
Okay. Start your presentation, sir.
Okay. Greetings of the day, everyone. Present here, myself, Anshuman Sharma. I would be presenting paper on efficient object detection, segmentation, and recognition using YOLO model, having paper ID 046.
Anshuman Sharma, sir, your voice is not audible.
Okay, sir. Okay. Hello. Is it better, sir?
No, not at all. Not at all audible. You have to use a good mic. I think the mic that you are using have some problem. Your voice is not at all audible.
Hello.
Please change the system.
Okay, sir. Hello. Is it better now?
Yeah, now it is okay.
Okay, sir.
You
Okay.
can carry on.
Okay, sir. So shall I start from beginning or?
Yes, you can continue.
Okay, sir. Okay, so I will continue. Okay, so presentation is structured as follows, starting with introduction, then moving to objective of research. Afterwards, discussing the motivation behind the study. Later on, we will be reviewing the methodology of work done. Subsequently, results will be presented and concluding the presentation with conclusion and future scope. So, introduction. In this segment, we will be discussing of the introduction of the work done. So, object detection. Object detection and recognition is a critical task in computer vision that involves automatically finding and localizing things of interest in digital pictures and movies. RCNN is the current state of the art of object detection approach. It generates a huge number of area recommendations using a selective search strategy. However, it is computationally costly and time demanding. To address this problem, one such approach is YOLO, that is, you look only once. Objective. Uh, Moving to objective of research, this study demonstrates how YOLO, you look only once model, was employed to conduct quick object recognition, segmentation, and identification. The paper comprises experiments on numerous images, and the findings reveal that the suggested technique detects and recognizes items with excellent accuracy and speed. Okay. Motivation. The following are the reasons for doing this following research. Learning and applying deep learning techniques to point and localize objects in an image. The primary impetus for the study was the recent introduction of deep learning architectures and the recent emergence of deep learning. So here we will be presenting with the methodology. Here it's the methodology of the work. First, we collected data using online sources. Then we visualized the data using inbuilt libraries. Then we built the YOLO model. And then we used detection and recognition techniques. And towards the end, we use the contour segmentation. Here are the results. As we can see, the accuracy achieved on localizing and detecting objects is pretty good using the YOLO model. So here are the two of the sample images. And here's the contour segmentation techniques that just borders out and differentiates the images with respect to each other. And the conclusion, so as discussed earlier, like in this paper we have presented the YOLO model for efficient object detection, segmentation, and recognition. YOLO model has basically several advantages over traditional object. It's fast, it's computationally not that high, and it has better accuracy. That's all, sir.
Okay, just go back to the result.
Sure, sir, sure. Sorry.
So, how many images you have tested?
Sir, it was around 700 to 750 images.
What is the accuracy of so how many objects were detected and how many objects were
Around
recognized?
we had 20 to 25 classes and it had around 700 images and accuracy was around 95, 96.
You need to mention it somewhere because see there are two parts in your multiple parts in your work, that is detection, segmentation and recognition.
Yes, sir.
So everything has a certain accuracy.
A certain accuracy. Okay, sir.
Yeah.
I
So
would
detection accuracy and recognition accuracy may not be the same.
Yes, sir. I get you, sir.
So what is the difference between detection and recognition? Can you tell me?
Sir, basically detection. Okay. So detection is like, basically able to, like, if I have this dog and this background, so basically it will detect, like it will differentiate it. And recognition is like able to classify what it is. So these are two different things. One is the one detects the difference and the other is what it is. Like basically
How do you compare? How do you evaluate your results? Because to tell that the result that you have obtained is correct, you
Yes,
should
sir.
have a known data set.
Yes, sir.
How did you evaluate all the 700 images, whether they are the output is correct or not?
So for that, the work, the YOLO model was developed from my side. Like that was the objective. So
Okay. You should have clearly shown the detection percentage and recognition percentage separately.
I should have shown that. Sorry.
Okay. Thank you. Bye.
Okay. Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Madam, only 265 paper ID, that is only pending. Remaining all are completed, madam. Just convey the information to your co-author, madam.
Yes, sir. Just give me 2 minutes. I'll just
Sure.
call her, or else I'll just start presenting.
You
Okay.
can start, madam. No issues. One person is enough.
Yes, sir, she wanted to be there. That's why I'll just
No
call
issue.
her once. I'll just give me 2 minutes, and I'm so sorry.
Or you can record your session and you can later share with them.
Okay, sure.
And presentation certificate will be given to all the authors. You need not worry.
Okay.
Srinivasa sir.
Sir.
From next time, from in the next conference, we shall that the authors be available during the session time, so that schedules are subject to be changed.
Yes, sir. Yes, sir. This time we faced.
Website in that case.
Sure, sir.
In that case,
now we are getting experience, sir.
Next time we will do that.
Sure, sir.
Very good, Srinivas. Actually, I'm like a great job. You have done excellent job. Very responsible. You have taken very good care of the 2-day session.
Thank you, sir.
Presenting the screen, sir.
Okay, madam.
Sir, I hope it is visible.
Yes, madam, it's visible. Now you can start, madam. Anyone?
Yes, sir. So yes, good evening one and all. Today, the paper I'm going to present is on hack investigation and probing using BEOS, that is brain electrical oscillation signature. So I'll just brief a little about BEOS. I'll just tell about myself. So I am Sarojorai Grandi. I am currently a lecturer at School of Criminology and Behavioral Sciences, Rashtriya Raksha University. I am from forensic psychology and clinical psychology background. So this particular system, that is brain electrical oscillation signature that I'm going to mention about, is basically developed as a forensic investigative tool based on the EEG system. So this is trying to record the EEG signals generated in a person's brain during the recording and try to elicit according to the probes or the stimulus basically that are presented to the subject, whether the person has experiential knowledge in him or not. So this is all developed on years of research on neuropsychology of brain, neurophysiology of brain, brain activations during recall and remembrance in the memory processes. Right. So this system is being used right now. In Gujarat Directorate of Forensic Sciences, even CBI CFSL Delhi, and even in Mumbai CBI CFSL. So the agenda, the main purpose of this study is to see, because so far it has been used in the conventional crimes, where a person has committed a crime where he has physically experienced whatever has happened. So when we have suspects, usually during a crime investigation, we have suspects. So when we have specific clues about some things, what only the perpetrator might be knowing, we try to present them as stimulus to the person and present them to the person to see if that particular probes or stimulus is eliciting experiential knowledge in the person or not. But when we are talking about cyber crimes, when it's totally happening online, cyber crimes which are totally happening online, and the main issue here is, it's though we might have many suspects even in cyber crimes, the authentic attributing the ownership of that particular evidence, because let's say a particular breach was traced back to a particular system, right? But the ownership of the system, again, from that particular point, the investigation process is very pretty much similar to the conventional crime investigation process, though there are other methods where we are setting and trying to see the online behavior of a person for 2-3 hours to find patterns and all. The thing is, when we are brought in with some suspects saying that they might have committed, again the process.
Saroja, madam.
Yes, sir.
We are not able to see the other slides. Okay.
I'm sorry, I didn't change.
Till now, it is in the first slide actually.
I actually didn't change. I was giving the preface. So yes, sorry. So that's what, when we are brought in with suspects, the procedure becomes similar to the conventional crimes, where we have suspects and we might have to screen them to see whether they have experiential knowledge in that particular element or not. So this research was done using presenting the probes which are specific to the crimes that were committed online. So so basically, we know that the rush to embrace new technology has exposed the world to a new category of crimes, that is cyber crimes and hacking. And in addition to advanced technical aptitudes, criminals have skills in linguistics and even psychology, and they've been using even social engineering deceptions to basically manipulate the decision-making process and even distort perceptions of the end users. So even the anonymity of cyber crimes increase the magnitude of offending and is obstructing the efforts to identify culprit, thereby distinguishing it from physical crimes. So this is arising the difficulty of attributing ownership and authorship to electronically stored information, and also in identifying individuals who were handling the device. So BEOS is a system used to detect markers of knowledge or awareness, which has an experiential basis in the individual. It was developed by Dr. C.R. Mukundan sir. And by the means of the study, we intended to find out how BEOS profiling can help in identifying the offender by using the techniques and actions of the procedure applied in attack, traced by analyzing electronic information obtained in the investigation for designing the probes. So it was divided into phases. So the sample size was actually 10, and the age group of the participants was between 20 to 25. And 5 were professional hackers and 5 were actually students who were pursuing their studies in cybersecurity. Right, and consent was taken from the participants, and they were requested to write step-by-step narration of specific hacking episode they have successfully accomplished in detail. And phishing, which is a common social engineering attack, was selected to make the standard set of probes. So 2 sets of probes were made to just compare. Right, and after the specific episode narrations, all 10 participants were step-by-step narrations were collected and entered into the WASP system. So I'll just, so this is BEOS. So it has 2 major subsystems. One is neurosignature system, which helps in acquisition of brain electrical activity, that is basically which is recording the brain activity, and WASP, visual and auditory stimulus programming, which is used for the purpose of recording the visual and auditory probes and storing them. And also it is the one presenting alongside the recording is happening, interacting with the NSS. Right. So phishing probes in sequence were entered.
Saroja madam, sorry to disturb you. The picture, please go back to the previous slide. Is this picture taken for your own experiments? Or is it downloaded somewhere?
Sir, this one is downloaded. I wasn't finding my pictures. So yeah, but this is the lab I used.
What I mean is, did you work from the dataset part, or did you really collect the dataset in real time?
Primary data, sir. It is from primary data.
So you are working on an already available dataset, right?
No. It is collected from primary data. I have collected the data. I have conducted BEOS studies. Sir, so I was a student in National Forensic Sciences University, where I was working on this particular system, which I still have access to. Yeah.
Okay. And then you could have included that pictures of.
Yes. I wasn't actually finding while making this PPT, sir. No, otherwise,
it's okay.
Yeah.
Carry on.
But it is the same lab. Yeah. So yeah, the standard set had 68 probes, and the specific set there were variations because probes were again segregated into 8 scenarios, counting control and neutral probes. We do include control probes during presentation to get a baseline of EEG. That is very important because to distinguish a person's EEG from any markers that we might find in the further analysis, right? So the specific sets consisted of 56 maximum numbers of probes and 79 number of probes, separated again into 6 to 11 scenarios, again considering the neutral and control probes as well. Event markers were also allotted to each probe, and these all sets were uploaded into the WASP system, and then they were recorded with the voice being gender specific to the participants. That helps in more stimulating the person more if the auditory probes that we are presenting are according to the same voice of the gender of the person. So they were then saved and they were presented. Yes, so the person wore a cap with 32 channel electrode and blunt needle syringe injected gel into the electrodes. So the cap here is a more advanced one which we use, because if you have seen a conventional EEG, each electrode has to be fixed separately. But yeah, as you can see in this picture, it is a cap coming itself with all the 32 electrodes. We just have to know the main points near the ears so that it is in its proper place. So a wire connected to the amplifier to the cap and reference point to the earlobe. And participants are asked to close their eyes for 2 minutes for baseline recording. Then the profiling recording was targeted and the probes were presented while the participants sat with eyes closed. 6 seconds separated each probes. The gap was necessary because, of course, the brain takes its time to process it once the stimulus is immediately present. Right. So we've just used descriptive statistics and little inferential statistics to see if there were major differences in the specific set and standard set. So yeah, this is the overall descriptive statistics percentage. So in specific probes, as we can see, the average probes presented were 55.4 and average EK, experiential knowledge generated, was 14.12. And in standard set of probes, that is of fishing, 59 were the probes and experiential knowledge elicited was 15.24. And in paid sample t-test between specific and standard probes, there wasn't much significant difference that was observed in both the sets. And actually, same thing even happened when we have separated the professionals and amateurs. So this is just the results focused on professionals. So as I mentioned, the group, there were 5 professionals and 5 amateurs. So these are the percentages that we could elicit in the professionals, that is 15.91 in specific sets and 13.55 in standard probes. And in amateurs, it was 12.61 in specific, and in standard, it was 17.12. But again, the t-test values haven't showed significant difference between the both. Right. So basically, the agenda was to see whether we are able to elicit experiential knowledge or not. Of course, the limitation is that we could have maybe compared it with some conventional crime probes, or at least a real-time experience that they have had and a virtual experience that they had during the hacking process to make it more reliable, let's say, to make it more evident that it can be used during hacking investigation. So it was explored and found that experiential knowledge of an individual who involves in hacking techniques and actions could be elicited using BEOS profiling by strategically designing the probes and using step-by-step techniques used by the hacker in cyber attack. And also it could be determined that BEOS profiling can be used for cybercrime investigation for identifying or at least screening the suspects when the cybercrime investigation turns problematic due to authenticity of identification of authorship or ownership of electronic information and evidence collected during cybercrime investigation. Yes, and also there is no electronic evidence or traces found during cybercrime investigation after an attack, but the type of attack or breach can be identified, right? So we can take the help of standard processes used in such attacks to design the probes for, again, conducting BEOS profiling, along with adding some specific details that which we might have observed while tracing back the breach that happened. So the limitations were, again, there was no control condition to counterbalance the findings of the study, since the specific set was based on subject specific personal experiences, and the length of experiences and the number of probes of each subject is specific set varied. And also specificity of exact experience in standard set of probes, it was observed that though never having done phishing, few have elicited experiential knowledge even in standard set on probes, referring to maybe most commonly performed actions. Because let's say some set of probes where it was mentioned, the probe was, let's say, they have opened or accessed Kali Linux or some particular elements which are common when they are even performing other functions. Because here when we're talking about probes, each probe is just a statement with 6 words. So we are breaking down them into small things. So when we are accessing a computer, there are many actions which are very common while we are performing different actions. Right. So as the study was conducted on very small population, it can be difficult to generalize it in an extensive manner. So for future perspectives, the study can be used in more extensive manner by conducting this profiling on actual suspects, by going through the electronic evidences gathered, building up or even tracing back the process of attack or breach with the help of experts, designing the probes, and then testing on BEOS to analyze the reliability and specificity. Yes, that's it, sir, for now.
Saroja madam, I think
Yes, sir.
the work is something interesting, which includes biological
Markers, yeah.
parameters,
Yes.
electronic parameters, and probes.
Yes, sir.
And one because actually, really speaking, new to this topic actually. So out of curiosity, I would like to ask one question.
Please, please.
Actually, how the probing data is collected using all those electronic probes,
Okay.
and how it is related to the hacking incident exactly?
Okay. Yeah, sure, sir. So I'll give an example of conventional crime. Maybe it will be just easy for now. So let's say we are trying to elicit whether the person had experiential knowledge of going to a particular place or not. Right. So when we are talking about investigations, we have a statement from the investigating officer, the expert, and also the suspect himself. Right. All might have different versions. So the narrations are converted into probes of statements each, and they are recorded into the system, sir. That is our neurosignature system, sorry, VASP, visual and auditory system. So there it is present, it is going to present to the subject who's seated and attached with the EEG cap in a 6-second interval. And sir, it is based on, again, as you also mentioned, it's on biological parameters. So there are particular parts of brain, like one is amygdala, limbic system, prefrontal cortex, occipitofrontal lobe. So these are some particular areas which are activated. So for each probe after presenting, the system is going to check whether these particular areas which are supposed to be activated when the person has actually experienced it is activating or not. Did I answer your question?
No, not at all. I mean, your terminologies are actually a bit unknown, so that's why I couldn't understand properly. My question is that assume that there is a suspect who has committed a hacking crime.
Okay.
Then now, what I understood from your presentation is that now you are investigating him by a set of questionnaire. And while you are asking the questions, you are recording these probes. Am I correct?
No, sir. So here, okay, I'll just tell what I have done here. So first thing, the narrations I've taken, I've asked them if they have committed anything or they had experience of anything. So let's say for the standard set phishing, I've asked multiple people how it is usually done. So online, the probes, each probe is like basically I have opened Kali Linux. Okay. This is the particular code I have entered. I have taken down the codes and what all they have entered, what all windows they have opened virtually on the screen while particularly doing it. Right. So phishing had many similar narrations. So I have made it according to that and the particular specific hacking experiences they have had. Even for, so there the codes and all they might have used, the software they might have used, the windows they might have used differed. So I have used them as probes in this particular instance. So
not the electromagnetic or the biological probe.
No. Sir, probes here I'm referring to the stimulus. Whatever is triggering them to remember or recall that have happened in their life or what they have experienced. So here, I'm so sorry. So here the probe, when we are talking in forensic psychological perspective, the stimulus that is being presented to the person to trigger some activity in the brain.
Okay, you are from which university?
Sir, right now I am working in Rashtriya Raksha University, Gujarat.
Okay, is it government?
Yes, sir. It's an INI. It's an Institute of National Importance.
Okay, okay. It is particularly dedicated towards security.
Yes, sir. It's dedicated to national security. We have 10 schools under the university. One is IT school, forensic science, behavioral science, defense studies, law. So, yeah.
Oh, very good. Cybercrime and hacking.
Yes, we have particular school, CETAC, School of Information Technology and Cybersecurity.
Okay.
Recent,
The admissions are through JE Advanced?
admissions? No, sir. It is so this was a state university before 3 years.
Okay.
So this and National Forensic Sciences University, I think you might have heard of.
Okay.
Both were nationalized under Ministry of Home Affairs in 2020, sir. So both universities directly come under MHA, Ministry of Home Affairs.
What is the admission procedure for this university?
Admission procedure? We have admission call. Students are asked to give university entrance exam, and based on that and merit, they are given.
You have your own entrance?
Yes, sir.
Okay. What programs? What UG and PG? Sorry, this is off the record. This is so your paper presentation is done. Just out of curiosity, I want to know something about your university. So this is off the record.
That's totally fine. So yes, sir, bachelors they have. So I am from different school. I am from School of Criminology and Behavioral Sciences. We don't have bachelor's programs. We have only masters and MPhil. But yes, IT school does have BTech program with specialization in data science and cyber security.
That is what I'm asking, madam. Like if BTech programs, what is the admission procedure?
It's based on merit, sir. We students apply and it's based on merit for now.
Okay. And the MTech programs as well?
Yes, sir. Yes.
Any GATE is mandatory, or is there
GATE is considered, sir. That's what it's based on merit only. Like GATE scores are also taken into consideration.
So students who have interest, but maybe let us say did not qualify in GATE, can they apply for the MTech programs?
Yes, sir. Surely they can apply. They will be asked to give the university entrance exam, and they are qualifying that, and they are falling. The rank is within the seats. That
Are there any campus placements for this?
Yes, campus placements are provided. I am not particularly sure about the percentage of placements, but yeah, as far as I'm known, they have been placed good, both even in National Forensic Science University and Rashtriya Raksha.
Where is it situated, madam?
Gujarat, sir.
Gujarat, very good. Okay.
Both were started by Narendra Modi.
Okay. Very good. Because actually, I am interested in cybersecurity. I teach and I am in the domain of cybersecurity. I would like to have some more interaction if there are any.
Director is Colonel Bhatnidhish Bhatnagar, sir, for the IT school.
Okay.
He is a very active and determined person. He's actually, we have in the IT school particularly, there are so many collaborations that are confidentially happening. So even NSA visited us recently, particularly to that school.
Yes. Thank you very much, ma'am, for your information.
Madam,
yes,
madam,
sir. Yes, sir.
Samples considered for this. Actually, you mentioned in the slide. I think you
so
did
all are white hat hackers, sir.
And test, I think, student sample test.
Yeah. So which sample? I'm sorry.
I think I think in the slide before the slide of conclusion, you highlighted that you are performing t-test, right?
Yes.
How many
paid sample t-test.
You in t-test also we have different types, right? Paid or unpaid, and
that's for paid sample t-test, sir.
Oh, paid. How many samples, madam, you collected?
Sir,
sample
it was
size.
10.
Okay.
Thank you,
sir.
sir.
Anything, sir? Ravi,
Yeah, that's all, sir. That's all from me. Thank you.
Thank you, madam. Thank you, sir.
Thank you, sir.
Myself, Dr. Shakiraman, sir. MJ College. Thank you, sir.
We can leave, sir.
Yeah, sure, madam. Thank you. Thanks for your presentation, madam.
Thank you, sir.
Thank you all. Ravikaran sir, can I conclude the session, sir? No one is there. Everything is completed, sir, except paper ID 4065. Ravikaran sir? Hello?
Sir.
Sir, over, sir. All presentations except 65.
Okay.
Sir, remaining marks filling చేశాను సార్ అది 46 to 65. 265
almost.
ఓకే సార్. వీళ్ళది బాగుంది సార్. ఐ థింక్ మనకి హ్యాకింగ్ సైబర్ సెక్యూరిటీ పాయింట్ ఆఫ్ వ్యూలో.
అవును.
స్టిల్లింగ్ వాళ్ళు ఐ థింక్ శాంపిల్స్
ఇది కంప్లీట్ గా మనకి టెక్నాలజీ అంటే మన ఐటీ కిందకి రాదు ఇది.
అదే వాళ్ళు జనరల్ గా బయాలజికల్ కాన్సెప్ట్ అంటే మనం చేసుకోవచ్చు సార్. వీళ్ళు ఇంకా శాంపిల్స్ చాలా తక్కువ తక్కువ తీసుకున్నారు.
అంటే ఇది యాక్చువల్ గా సైబర్ క్రైమ్ అంటున్నారు. అసలు పూర్తిగా అర్థం కాలేదు నాకు అసలు కాన్సెప్ట్.
అదేంటంటే వాళ్ళు బయాలజికల్ నుంచి ఇందులోకి వచ్చారు. అయితే we can use that data to our side, sir, software side. అది మనకు వాళ్ళతో ఇంటరాక్ట్ అయితే తెలుస్తుంది వాళ్ళ ఐడియా ఏంటి అనేది.
అవును.
అది సార్ అయిపోయింది. రికార్డింగ్ క్లోజ్ చేస్తాను. నార్మల్ గా మాట్లాడేస్తున్నాను.
yes sir, you can close చేసేయండి సార్. రికార్డింగ్ క్లోజ్ చేసేయండి. ఓకే, ఇంకేమన్నా